Hey, Katie.
Hey, Ben.
So, elections. I've been hearing that Donald Trump is doing well in counties with white suburbanites.
Oh, and what does this lead you to believe about Donald Trump's performance with white suburbanites?
I, I mean, it seems like he's doing well with them because he's doing well in counties that have a lot of white suburbanites. So,
Oh, Ben, you have just committed an ecological fallacy.
ah,
You are not necessarily correct, sir.
okay. I wanna know why. But first, you are listening to Linear Digressions. Okay, I feel bashful and sheepish. What did I do wrong?
You have done something that a lot of people do, and it's easy to do. That's why we're talking about it.
So it's not just me.
Oh, no, definitely not you. And this episode was, first of all, inspired by a listener email. This came from Mike Lynch this week. Thank you, Mike. Although I have to say, this was kind of stewing in our heads for a few weeks about as something that we could talk about. So Mike kind of got us off our keisters.
Awesome.
Yeah, so we're going to be talking about ecological inference, ecological fallacy, and then Simpson's paradox, which is a particularly interesting and pathological case of an ecological fallacy. So here is what you did, and this is a case of first ecological inference, and then I'll explain to you the fallacy. So the inference that you're trying to make is you say, I look at some election results that are coming in. I see that Donald Trump is doing well in a county that has a bunch of white suburbanites. We're kind of making up this example, but you can very
Sure.
easily, imagine many parallels that are going on right now.
Yeah, I have not been following Donald Trump's granular performance in counties across like that is not something I'm interested in doing. But
Okay, well, that might be for the best. But so you say that Donald Trump is doing well in a particular county. That county has a bunch of white suburbanites. Therefore, the conclusion I draw is that Donald Trump is doing well with white suburbanites. And this is, on face of it, a reasonable thing to say. However, it's entirely possible that you are precisely wrong, because there are people other than white suburbanites who live in any given county. And what could very
Oh.
easily be the case is that he's doing well with everyone else except for the white suburbanites. And so even though you've had something that on face looks like a fairly reasonable thing to say, once you drill down into a specific subgroup and you try to take the trends from the larger group and apply them to the smaller subgroup, in this case, the trend that he's doing well in this county, and therefore say that this subgroup, the white suburbanites, he's doing well with them, that is a case of ecological fallacy.
So I have a question, because my kind of gut check on this is that technically, yes, he might not be doing well with white suburbanites, and this might be a coincidence, but it feels like something that wouldn't happen all that often. Like I would be right most of the time. Is that necessarily true? Or I mean, I'm also not a professional data scientist, so
Oh, that's a good question. I mean, it's hard to say how often people make statements like this and then how often they're wrong. I think certainly people make these statements more often than they can truly be backed up. But in terms of how big of a problem is this quantitatively compared to how often you would reach the correct conclusion using this reasoning, I'm not exactly sure. However,
Right.
I do know that people say this sort of stuff all the time, and there's a big enough risk that you could exactly be wrong that I think it's definitely worth being
Got it.
aware of this as a problem and checking yourself before you start making
it's-
claims
so
about
it's
the yeah.
kind of like correlation versus causation, where some of the time you may be right, and maybe even in a particular class you may be right most of the time, but the problem is not whether you're right or wrong. The problem is you believing that that logical inference will always be right.
Yeah, I mean, you're basically saying something that could be right or it could be wrong. And,
Right.
just like
Yeah.
sometimes it'll be right, sure. It just in the same way that, sometimes if I think that walking out on the street, I'm going to, I don't know, see a clown. Occasionally I'm right because it's Thanksgiving and there's a parade staging outside my house or something. But, but there's no particular reason to think that I've actually made a statement that gives anyone any insight into the world. I've just made a statement that may or may not be correct, and
Okay.
it's kind of a coin flip. And so, and this is actually, it can be a really important thing to get correct in certain circumstances. And in particular, I think it's important for elections because people do this all the time with elections, and it's not always being done by people who totally understand what they're talking about. And so this gets can be more of a problem, I think, sometimes when people are trying to deal with electoral politics than in some other contexts. But certainly it comes up very often. One of the cases I was reading about when I was researching this, though, is there was a case in 1994 where they were trying to figure out if there was gerrymandering of this district in Ohio that would be disenfranchising systematically black voters in a way that would be violating their civil rights.
Okay.
And so here's what happened in that case is they have... Here's what you need to sort of demonstrate in order to have a successful lawsuit is you need to show that not only are black people potentially voting in proportionately lower numbers than their white counterparts, but that black people are voting for different candidates than their white counterparts, such that if black people were voting in sort of their full strength, that it would actually change the outcome of the election.
Got it. So not only are they actually being disenfranchised, but because of the disfranchisation, is that a word?
Disenfranchisement?
Thank you. Yeah. Because of the disenfranchisement, that actually meaningfully changes the outcome.
Exactly. So what you need to know is sort of the proportional support that black people give to, in this case, presumably they would be supporting, there was a black Democratic candidate, and then there was a white Republican candidate. And the idea is that the proportions of how black and white people support each of those candidates will be different. And so there's kind of a matrix that you can draw in your mind.
Okay.
The columns of the matrix are the votes that are received by each of the candidates. So column number 1 is the votes that are received by the Democrat. Column number 2 is the votes that are received by the Republican. And then the third column is people who abstain from voting. And then there's also, so we have 3 columns, and there's also 2 rows in this little table that we're drawing. And so The first row is the black people, and then the second row is the white people.
And I guess for sake of argument for this example, we're assuming that there are only 2.
2 races, yeah.
Right.
Yeah. And so then we have aggregated information that sort of summarizes each of the rows and each of the columns. So we have from demographic tables, we know how many black people live in this district, and we know how many white people do. And then from the election returns, we also know the vote totals that went to the black candidate, or the Democratic candidate, the Republican candidate, and the no vote, the abstainers. And so we sort of have the margins of this matrix filled in. But the question is, we need to fill in the inside cells. So it's not how many black people live in this district, but how many black people voted for the Democrat, how many black people voted for the Republican, and how many voted for voted for nobody, how many people abstained from voting.
And then the same numbers for the white people in the district.
Exactly. So the question is, what goes inside of this table? And the short answer is there's no way to know from the data that we have right now.
Yeah,
and
there's just not enough data to extrapolate that.
Exactly. And there are people who try. In fact, the example that I was reading had this, kind of amusing but also kind of upsetting example of how there was an expert who was called in to testify on this exact issue, and they had some methodology for kind of extrapolating or making educated guesses, I don't know, from some of the methods that they have in this field, and ended up coming up with conclusions like 110% of the black people voted for the Democrat and negative 4% voted for the Republican.
That's wrong. That's clearly wrong.
Yeah, I think in physics we would call that a non-physical answer.
A non-physical, okay, yeah.
Yeah, so, and that just emphasizes for you, first of all, how easy it is to fall into this trap, because obviously these are nonsense answers that if there's 55,000 black people living in this district, you can't get 58,000 black votes for a Democrat. It's not mathematically possible.
Right.
And this was a mistake that was being made by an expert. So you would think that, of all people, this would be an individual who would be wary of these kinds of mistakes. And so the fact that they were being made just shows you how difficult of a problem it is and how sort of it can sneak up even on people who ostensibly know what's going on. So you really, I think, have a lot of reason to be worried about this as an analyst if you're trying to make these kinds of conclusions where you're looking at trends that hold in the larger population and then from that draw down to the smaller population. You just have to be really, really careful. And in general, it can't be done.
Okay, so that's all good. You did mention one other thing in the intro that we were going to talk about, which is Simpson's paradox.
Oh, yeah. So this is a special case of ecological fallacy.
Right.
So I was saying that with an ecological fallacy, you can sometimes reach conclusions that are not necessarily correct or they can be wrong. Simpson's paradox is looking at examples of where you get exactly the wrong conclusion.
Okay.
So the idea with Simpson's paradox is it's cases where you have one trend that holds in a larger population, but then as soon as you start breaking that population into subgroups and you look at the same sort of relationship in the subgroups, you have exactly the opposite trend of what you have when you have everyone grouped together.
Now, all else being equal, that does seem like a paradox.
Yeah.
Like the whole is doing one thing, but when you look at any of the individual pieces, they're all doing the opposite.
Yeah, and it's really diabolical, and it's one of those things that makes you kind of shake your head when you hear about it the first time. But
so it feels like there's got to be some catch somewhere.
Well, so let me give you an example, and then it might give you a little bit more of a gut check on like what does this look like. So this is a real example. This is looking at the median U.S. wage since 2000, and the question is, adjusted for inflation, has the median U.S. wage gone up, gone down, stayed the same since the year 2000? If you look at the entire U.S. population, the answer is it's gone up. It's gone up by not very much, about 1%, but it's gone up.
Okay, so you're saying that what was the year, 2001?
2000.
In 2000, the median wage was something, and then more recently, 2014 or 15 or 16, whenever those numbers were taken, then it's the same number but 1% higher.
Yeah, I think this was probably in 2012 or 2013 from when the publication date on this blog post is, but yeah, it's
Sure,
1% higher.
Okay, cool.
So the conclusion from this is U.S. wages are on the rise. Let's feel good about this. But then what you can do is you can break the population down into a number of subgroups. And we're going to break them down into subgroups by education level. So we're going to split it into 4 groups, which are mutually exclusive. You have the high school dropouts. You have people who graduate from college but do not have, or who graduate from high school, but do not have a college education. You have people with some college, and then people who have graduated from college and perhaps have higher degrees as well. So we're starting to control, we would say, control for the effective education. And so now we have these 4 groups. Between the 4 of them, they encompass the entire population because everyone in the United States falls into one of these 4 groups. Mm-hmm. And then we look at the trend of wages in each of these subgroups. And we find that the wages have declined since 2000 in every single one.
Down.
They've gone down in every single one of these subgroups.
Okay. See, that seems paradoxical, hence the name Simpson's paradox. Because if you have all of these 4 groups and they're all going down, if you put them together, surely that total should go down as well.
And yet it does not, and that's the paradox.
Okay. So what's the catch? It seems that if we're comparing apples to apples, if we're comparing the same thing in 2000 with the same thing in 2012 or 14 or whatever year it was, then those vectors should be going the same direction, not opposite.
So what's going on in this particular case is that people were actually changing which groups they fall into. So the relative composition of each of the groups was changing. So even though it's correct that the trend is sort of downward in each of these subgroups, we find that the proportion of people who, for example, were high school dropouts in 2000 was a higher proportion of the population than high school dropouts in 2012. And the proportion of people with bachelor's or higher degrees was lower in 2000 than it was in 2012. Basically, people are getting more educated, or in general, the demographics are shifting towards more education. And so even though within each group the wages are going down, the fact that you're migrating from one group to another overall pushes the median wage in a direction that is trending up.
Okay, so we're not comparing apples to apples exactly. If we're comparing everybody to everybody, we're a little bit closer to apples because we're comparing everybody in the population in 2001 to everybody in the population in 2014 or something like that. Mm-hmm. But when we look at the smaller groups, we're not really comparing the same people. We're comparing a category, and those categories are changing size. And so the categories with higher income are actually getting bigger, and they're getting bigger faster than their wages are going down.
Yeah. So then the overall trend is towards more money, but it's all being driven by the fact that people are getting more educated and not by the fact that that wages are just sort of organically rising.
So as much as this seems like a paradox, it's not actually a paradox. It only feels like a paradox when you're not taking into account all of the things that motivate these numbers to change in one direction or another.
Well, that's it exactly, is that Simpson's paradox is something that can arise and give you the wrong answers when you don't have sort of like the correct, quote unquote, variables available to you when you're doing your analysis. And so it's something that, again, you have to be very careful about and very thoughtful of if you're trying to do some kind of analysis, that you think about if there are relevant factors that aren't being taken into account in your analysis. In this case, you have to be taking into account education in order to see this trend. If you were just looking at the wages on their own, you wouldn't see it. And so I don't have any particularly great recipes for never falling victim to this, because you kind of have to know to look at the right variables, or you have to look at a lot of control variables and make sure that you're just sort of checking everything that you have the ability to check. But it's something to be aware of, that once you start to make extrapolations, or maybe you would say interpolations, from big groups of people down to smaller groups of people, that you're definitely opening yourself up to, ecological problems. So just that you don't necessarily know if the trends are holding, and in fact, you could very well be falling victim to Simpson's paradox and you're getting things exactly wrong. So be careful if you're going to make a statement about a subgroup. Be sure that you've actually checked that subgroup and that you're not just taking a conclusion that holds for the supergroup and saying like, well, if it's true for the bigger group, then it should be true for the smaller group, because that is not necessarily the case.
Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.